we back again for chapter 5 alcohol. So this is part 2. Okay, so today we will look at the physical properties of the alcohol. Okay, so before we delve into the physical property of alcohol, we must look first at the structure of alcohol. Okay, so let's recap about the structure of alcohol, because it is important for you to understand how the structure of alcohol will affect the physical properties of the alcohol. Okay, so for example, I have here is your propanol. Okay, so we have the hydrocarbon chain, meaning that the carbon chain itself. Okay, so this carbon chain is non-polar. But for this hydroxyl part, okay, so the hydroxyl group here, OH group, is polar molecule. Okay, so let's make this alcohol polar molecules overall. So this differ from the alkane that we learned before. Okay, alkane only have hydrocarbon chain, meaning it is non-polar. Okay, so how it affect your boiling point, for example. Okay, you must remember in alkane we only have van der Waals forces, or specifically we have London dispersion forces for non-polar molecules. Okay, so your boiling point is not very high because it is a weak intermolecular forces. Okay, remember that. Okay, but what happened in alcohol? For example, you have pure inside this conical flask, you have pure propanol. Okay, we will look at the interaction between the molecules of propanol inside the chemical flask name. An important info to look at is this alkyl chain part, or just R chain is slightly positive, and this one is the hydroxy part is slightly negative because of the electronegative oxygen there. Okay, so if we look at the inside of this pure propanol, so that we can know how the interaction between the propanol itself. Okay, so you have the alkyl chain, and then you have your hydroxyl group. Okay, so what happened is most of them will end up like this. This is because of the formation of a hydrogen bond. Okay, so remember, hydrogen bond is a bond formed between hydrogen and F, O and N, meaning hydrogen with fluorine, hydrogen with oxygen, and hydrogen with nitrogen. Okay, so all these three interaction we call it hydrogen bond. Okay, so one alcohol have one hydroxyl, OH. Okay, so both of them, they are identical and they can form hydrogen bond between them. Okay, between oxygen and hydrogen. So we have hydrogen bond here, and then we have hydrogen bond here. Okay, you must remember that the oxygen is have an interaction with a hydrogen because of oxygen is slightly negative, hydrogen is slightly positive. Positive, negative. Okay, opposite attract. That's how it differ from the alkane. Okay, alkane only have London dispersion forces, but alcohol we have an additional strong bond, hydrogen bond. So let's get back to the physical properties. So the physical properties, we will look at two different things. Okay, the first one is boiling point, and the second one is solubility. Okay, so when we want to discuss about this thing, you have to, the most important thing is you have to understand how it works. Okay, so for boiling point, you want to look at the intermolecular forces between alcohol molecules, meaning in between alcohol and alcohol itself. Okay, but in solubility, you want to look at the intermolecular forces between alcohol and water, meaning you want to look at alcohol and water, what happened between them. Okay, so let's look at the boiling point. Okay, we have two cases. The first case, you may find they want to compare between alkane versus alcohol. Which one has the higher boiling point? Okay, so alkane, for example, you have propane, and then for alcohol you have propanol. Okay, so you have the same number of carbon, only with propanol you have additional, of course, hydroxyl group. Okay, so in this case, your propanol will have higher boiling point than your propane. Okay, why? You have to remember the alkane. Okay, alkane only have weak van der Waals forces. Okay, these weak van der Waals forces come from the alkyl chain. Okay, the hydrocarbon chain. Okay, but for propanol, okay, for alkyl chain, we don't look at this because we have the same number of alkyl chain, the same size for alkyl chain, so it's not our factors here. Okay, so the only difference is the presence of the hydroxyl. Okay, so this presence of hydroxyl, so when you have hydroxyl group, remember that you can form hydrogen bond with yourself. Okay, intermolecular hydrogen bond between alcohol molecules, in this case between propanol molecules. Okay, so why a hydrogen bond? It is a very strong intermolecular forces. Okay, so strong intermolecular forces, it will need larger and higher energy to overcome the forces, so that's why it is higher boiling point. But in second cases, it's between both are alcohol. Okay, so we look at what's the difference between them. Okay, so we have here our propanol, and then we have, okay, 4 carbon, so we have our butanol here. Okay, so let's look at what's the same thing here. Both are alcohol, so both have one hydroxyl. Okay, so in this case, your hydrogen bond, your hydroxyl is not going to be the factors that we want to investigate. Why? Which one is higher? Okay, so in this case, we look at the size of the molecule. Okay, or the size of the alkyl chain. Okay, so the size of the molecule, this one will have a larger size because they have a larger number of larger number of carbon. Okay, so remember, for alkyl chain we have van der Waals forces. Okay, so van der Waals forces, so obviously your butanol, okay, will have stronger van der Waals forces compared to your propanol. Okay, your propanol is small, so it have a weaker van der Waals forces. So in this case, our factors that to be focused on is the van der Waals forces. Okay, because they have the same number of hydroxyl. Both have hydroxyl, both have one hydroxyl, so both have the same hydrogen bond. Okay, same strength of hydrogen bond. So the only difference is the strength of your van der Waals forces. So your butanol have higher boiling point than your propanol. Okay, so the strategy on how you want to find out which one is have the highest boiling point, we look at the factors affecting the boiling point. So we have 3 main factors here. So the first one is the number of hydroxyl group. Okay, so the first thing you have to look at is you look at how many hydroxyl group that those compounds have. For example, if the compound 1 have 1 hydroxyl group, compound 2 have 2 hydroxyl group, so you know which one will win. Okay, so if the compound have more hydroxyl group, it will have of course more hydrogen bond. Okay, because hydroxyl group meaning you can form hydrogen bond. If you have more than one hydroxyl group, you can form more hydrogen bond. Okay, so hydrogen bond is strong. So if even one is high boiling point, so if you have more than one, then you have higher boiling point. Okay, so the one with the highest number of hydroxyl group will win lah. And then the second one, for example, if all the compound have the same number of hydroxyl group. Okay, so you cannot use this, and then you go to the next factors. So you look at the size of molecule. If they have a different size, meaning different number of compound. Okay, for example, that compound have larger size compared to the other. So when you have larger size compound, you will have larger alkyl chain. So when you have larger alkyl chain, meaning you will have stronger van der Waals forces. Okay, if stronger van der Waals forces, you will have higher boiling point. Okay, so in your explanation, make sure each factors you will include the type of bond that form. Okay, in every explanation using the factors. Okay, and then the last one, if you have the same number of hydroxyl group, even the number of carbon is the same, and then you look at the last choice, you look at the shape of molecule. Okay, if those two are the same, then this one will be your choice lah. Okay, mesti ni yang akan jadi lain lah. Okay, so that is the shape of the molecules. We look at whether the shape is straight, or kita panggil dia linear molecule, or branch. Okay, linear like this, or you have something like this, you have branch. Okay, so if it's branch molecule, okay, branch molecule, you have a smaller contact surface area. Okay, so when you have smaller contact surface area, you will have weaker van der Waals forces, and then you have lower boiling point. Okay, so let's look at solubility next. Okay, the solubility, okay, remember we want to study the interaction between alcohol and water, whether there is a forces between them, intermolecular forces between them. Okay, so to study that, okay, for example, you have a conical flask, and then you put your propanol inside together with water. Okay, because we want to see the interaction between those two. Okay, so this is your propanol. Okay, so you have your alkyl, you have your hydroxyl, and then this is water. Okay, water. Okay, so this is the structure of water. Both have the OH. Okay, so what happened here is water is also have a polar, it's also a polar molecule. So alcohol is polar molecule, water is polar solvent. Okay, so both are polar, they will have a hydrogen bond. Okay, because this one is slightly negative, slightly positive. So what happen is they will attract each other. Okay, so this will hydrogen bond. Okay, so between alcohol and water, you will have hydrogen bond, intermolecular hydrogen bond between alcohol and water. Okay, this is very easy for solubility. If your compound, your organic compound, can form hydrogen bond with water, then it means that your compound is soluble in water. Okay, it dissolves in water, meaning when you add those two inside, you will not find any two layers, it is just one layer. Okay, because it is soluble in water. So the first the factors that are affecting the solubility, we only have two for solubility. So the first one is the number of OH group. Okay, so the first thing you look at, if that compound have more hydroxyl group compared to the others, okay, meaning that it can form more hydrogen bond with water. So if you can form more hydrogen with water, of course you will become more soluble, meaning solubility will increase. Okay, so for example, you have pentanol and versus pentane diol. Diol meaning you have two OH group inside compound. Okay, so of course your pentane diol will have higher solubility. Okay, so the second factors is you look at the size of molecule. For example, if your compound both have the same number of hydroxy group, and then you look at the second factors lah. Okay, so the second factors is the size of molecule. If one of that have the larger size, for the larger size molecule, meaning you have bigger weight, so the largest size molecule, okay, that refer to the larger alkyl group lah, meaning larger or higher number of carbon. Okay, so larger alkyl, so you have to remember your alkyl is non-polar. So non-polar, it is hydrophobic area. Okay, what mean by hydrophobic? It is have a easier for you to remember, it have phobia with water. Okay, dia tak suka dengan air lah. Okay, so large hydrophobic area which tend to repel H2O. Okay, so if the part with the phobia with water is larger, of course your solubility will decrease. Okay, so for example, you have ethanol. Okay, so ethanol with 2 carbon compared to butanol with 4 carbon. Okay, so your ethanol is more soluble, your butanol is less soluble. Okay, because this part here, this alkyl here is 4 big with water is larger compared to ethanol, only have smaller hydrophobic area. Okay, that's all. Thank you.